Okay, so today's lesson is going to be on tangents and circumscribed angles. Make sure that you are on page, or you attach this to page 41. And today is the 21st, right? Okay, so first thing I would like you to do is draw a circle off to the side here because we're going to fill in some information. So we're going to use problems 1 through 4 and fill in the blanks. And this is all like definition stuff. Okay, so number 1, a line in the same plane as a circle that intersects the circle at exactly one point is called the tangent. So if I were to draw in a tangent, it would look something like this. Okay, it's intersecting the circle at this point here. This is my tangent. Now that line, this is technically a segment, but it can go all the way through, okay? It doesn't have to just stop, but for our purposes right now, it's going to. Number 2, if two segments are tangent, so if I have another segment that's tangent to this circle, and two segments are tangent to a circle from the same external point, so this tangent line meets that one at that external point, then those segments are congruent. Okay, so this segment will be congruent to this segment. So far, so good? Okay. If a line is tangent to a circle, so this is my tangent line, then it is perpendicular to the radius drawn to that point of tangency. So I'm going to include the center of this circle. And how would I draw in a radius? How would you start to draw a radius? So you start at the center, and you can technically connect it to any point of the circle, right? But we're talking about to the tangent line. So I'm going to go from the center to this tangent line. And that angle is 90 degrees because they're perpendicular. So if your tangent line and your radius intersect, they are going to intersect perpendicularly. Okay? I can draw another one in here, and it will be the same thing. And then lastly, we have a circumscribed angle of a circle and its associated central angle. And those two angles are going to be supplementary. So let me label some things. Can someone tell me what the central angle is going to be? Angle C, or angle ACB, right? Here's my central angle. We know that from prior lessons. That's the central angle. Any guesses on what my circumscribed angle will be? D. It's this angle that was formed by our two tangent lines. So this is my circumscribed. Okay, that's my circumscribed angle. So the central angle and the circumscribed angle are supplementary, which means they equal what? 180. Good. Any questions on the definitions? No? Okay. So we're going to use some information. So use the figure for problems 5 through 7. AB, so here's line AB. It is tangent to circle C at point B. AD is tangent to circle C. This should say at point D, not point B. That should say at point D. Answer the question to determine the measure of angle BCD. The first one is done for you. All right. So angle BAD, which is what angle? What's the name of that angle? BAD. The circumscribed angle. And BCD, which is the central angle, are supplementary. Okay, so because it's the central angle and the circumscribed angle, they're going to be supplementary. Can we write an equation to help us solve for x? 60 plus x equals 180, because they're supplementary. Can we solve for x? If we subtract 60, we get x equals 120, which means our central angle equals 120. Everyone okay with that? Yeah? Okay. So here we're going to refer to the figure. So GH is tangent to circle J at point H. GI is tangent to circle J at point I. Answer the following questions. Okay. So GH is a tangent line. GI is a tangent line. And those two lines are congruent. Why are they congruent? In your own words, what did the definition say?
They start at the same point on the circle.
Okay, so if they both intersect the circle once and then meet at the same external point, which in this case would be point G, then those two segments are congruent. Okay, so they intersect the circle once and meet at the same external point. Can we write an equation to solve for x? 2x equals x plus 12. They're congruent, so you would just set them equal to each other. And I can solve for x. So I would subtract x, and I get x equals 12. And I want to know what GH is. How'd you get 24? You plugged it in, right? 2 times 12 is 24. If I plug it into GI, should I get the same answer? Yeah, because they're congruent. Do you get the same answer? Yeah, 12 plus 12 is 24. That's a quick check for you. So if you have to solve and you get a value for x, both of these should be the same. So I would plug them back in just to make sure they're both equal and you didn't mess up with your adding, subtracting. Still good? Okay. So let's go through this first part together. Change in the directions, change this B to a D again. I don't know why it has a B. It should be a D. All right. We want to find the measure of angle ABC. Locate angle ABC. Everyone found it on their paper? Anyone know what the measure of that angle is? 90 degrees. Because you have a tangent line that intersects a radius. So that angle is 90 degrees by definition. It's where a lot of people mess up. Okay, you just have to know that definition. There's not anything to solve for there. I want to find angle DCB. What angle is that? The central angle. How can I find the central angle? It's supplementary with the circumscribed angle. So I'm going to call the central angle x. X plus 40 equals 180. If you subtract 40, you end up with 140 for the central angle. All right, now we need to find BDA. So I want you to locate angle BDA. Okay, now look on your paper. BDA is just this piece here. Okay, so if it was asking for CDA, it would be 90 degrees. But it's not. It's asking for just that piece of it. Any ideas what the value of angle BDA is? Triangles what? Triangles equal 180. Okay, so I know this one's 40. And, well, this one here includes two triangles.
Yeah.
So not just this piece is 90. It's like this whole thing here. Yeah.
Should you solve for CDB before solving for DEA? Because if you did, wouldn't you get like 20 for the one that's in the triangle? And then if you think about it like a transversal, wouldn't it be 160?
No, because in order for it to be a transversal, the lines have to be parallel.
Can you think of it as a triangle and then just subtract the 40 from 180 and divide it by 2?
Okay, so let's think about that for a second. So I'm going to take this triangle. So this is A, this is B, this is D. I know this is 40. And Alex said, okay, I know a triangle equals 180 degrees, right? So 180 minus 40 is 140. Why are you dividing it by 2?
So the same.
Why are they the same?
The tangent lines are congruent.
Okay, so these lines here are congruent. That's going to be important. What kind of triangle is that? Isosceles. Okay, so if two sides of a triangle are congruent, it's an isosceles triangle. Now, if you think back to IM1, there was a definition you got. And it said that if you have an isosceles triangle, the base angles are congruent. So yes, we would subtract 40 from 180 and we'd get 140. But because it's isosceles is why we are allowed to divide it by 2, which means each of those angles is 70 degrees. Okay, so this angle here is 70 degrees. So you need to understand the reason. We are allowed to do that because it's an isosceles triangle. Do you see another isosceles triangle in that figure? Triangle what? DCB. Why are these pieces congruent? These two here with the double tick marks. Why are those pieces congruent?
Because they are.
What is this line? What did we say this was? A radius. Right? Doesn't matter where you draw a radius in, all the radii are going to be congruent to each other. Right? Okay, so we want to find, now there's two ways to look at number 4. We want to find angle CDB, which is, let me grab a different color. 1 second, Bailey. Which is this piece up here. Were you going to answer the question for me? What do you get? 20 degrees. Okay, so there's two ways to think of it. I can think of it as, I know this whole thing's 90, right? Because the radius and the tangent make a 90-degree angle. So 90 minus 70 is 20. Or I can look at it as an isosceles triangle. I know my central angle is 140, which means I have 40 degrees left for both of those little angles. You would divide it by 2, and you would get 20. Okay, so either way works. Are you okay with that? I would like you to try problems 5 through 8. Try problems 5 through 8. So let's look at 5. Okay, so 5, we're looking for angle BCD. Which angle is that? The central angle? Okay, so x plus 32, because that's my circumscribed angle, equals 180. If I subtract 32, I get 148. So far, so good? Okay. What is the measure of angle CDA? 90. Because you have a radius and a tangent. Let's skip 7 for a second and go to 8. What is the measure of angle DBA?
74.
Okay, so how did we get 74?
Divided by 2. Divide 142.
So you have an isosceles triangle, right? Because these pieces are congruent. You have an isosceles triangle. You know that 180 minus 32 is 148. Because these sides are congruent, the base angles have to be congruent, and 148 divided by 2 is 74. All right, so now we need to figure out angle BED. What is angle BED? Like, what's the name of it? An inscribed angle. So I know that this angle is inscribed, and I know it forms this arc. So if I knew what the arc was, I could figure out the angle, right? So what's the arc? Why is it 148, Adrian?
Because this is 140. I don't know.
What's this angle called? The central angle. The central angle and the arc that the central angle creates are congruent. Okay, so here's my central angle. The arc that it creates is going to be congruent to my central angle. How do I find the inscribed angle from that arc? Divide by 2, which is 74. Are we okay with that? Yes? Okay. All right. Number 9. I have a central angle and a circumscribed angle. What do I know about them? They're supplementary. So 2x minus 7 plus x plus 1 equals 180. If I combine like terms, I get 3x minus 6 equals 180. 3x equals 186. And when I divide by 3, I get x equals 62. Okay, if you can solve for x, then everything else is a matter of pretty much plugging it back in. So NQM is this angle up here. 62 plus 1 is 63. What's the measure of angle PNQ? 90. Because it's the radius and the tangent together. And then I want NPM, which is this angle up here. So 2 times 62 minus 7 is 117. I want you to solve number 10. So it's the same thing, solve number 10. So did you get 2x minus 2 plus 6x minus 10 equals 180? Yes? And what'd you get for x when you solved?
24.
Everyone got 24? Okay. If I plug that back into MQN, I end up with 46. Great. What is the measure of QMP? Awesome. And if I plug that back into angle NPM, you end up with? Huh? Thank you. Did we get all those? Great. All right, let's look at the last 2 problems together. Okay, so here we have tangent lines. So EF and EG are tangents. What do we know about those tangent lines if they meet at that external point? They're congruent. So we know those 2 lines are congruent, or segments, excuse me. So how would I set up an equation? (3x minus 1.2 equals 2x plus 1.8. Okay, Okay, I'm going to solve by subtracting 2x from both sides, leaving me with x minus 1.2 equals 1.8. And I'm going to add 1.2. If you are doing this adding by hand, you need to make sure you line up those decimals. But you end up with x equals 3. Now I want EF. So if I plug it back in, 3 times 3 is 9. 9 minus 1.2 is 7.8. If you plug it back in over here, you should get the same answer, do you? 2 times 3 is 6, plus 1.8 is 7.8. All right, last one. Can someone help me set up an equation? You can set up the equation. 5x. Okay, 5x over 1 equals x squared over 2. I like that. And how would I solve that equation? Cross multiply. Good. So 10x equals x squared. Now I need to get x by itself. We can't divide by x here. Okay? We can't do that either. We can't find the square root. Any other ideas? It is not unsolvable. Because that gives me 0 equals x squared minus 10x. What do I do with that? No, we're not putting the 10 back. The 10's going to stay there. What do we do with that? Who said that? Alyssa. Oh, Kat said it? Take an x out? What's that called? Starts with an F. Factoring. It's our favorite F word. Okay, so we are going to factor out our greatest common factor, which is x, which leaves me with x minus 10. Can I solve for x? Yes? What's x going to be? The zero product property says that I can set each of those factors equal to 0 and solve. So x equals 0 and x equals 10. This is from first semester. It is a very good review because you are going to need this for IM 3.
Why did they use it at the beginning of the year then?
Okay? So, right now x equals 0 and x equals 10. Are we okay with both of those answers? Okay, you have to tell me why if you're going to say no. And you have to tell me why if you're going to say yes. No, why?
Because both those lines are equal.
Well, okay, so if I plug in 10, for instance, 5 times 10 is 50, right? And 10 squared is 100 divided by 2 is 50. So that works. Kat?
Not the 0, because if you plug in 0, you can't have a 0 distance.
Okay, so if I plug in 0, 5 times 0 is 0. You cannot have a distance of 0. Okay, that length is obviously greater than 0. So x equals 0 is not going to work in this case.
Can one work but not the other? Is that okay?
Yeah, here. So if we got x equals 2 and x equals 10, which we wouldn't, but if we did, both of them technically work, we'd keep both of them. So remember when we were factoring before? Like on word problems, we factored and we got one value, or we got like a negative value, and then the positive value, we couldn't use the negative because then we'd have a negative distance. So that's what's going to happen here if you have a problem like this. Okay?